Alright guys, so this is the first video of 9.7, which is the final section of chapter 9. So this will conclude our trig chapter, at least new stuff in our trig chapter anyways. And this section's all about how we can solve triangles if they are not right triangles. So none of the angles are right angles. What can we do? Because remember, in order to use SOHCAHTOA, we have to have right triangles. In order to use special rights, we have to have either 30, 60, 90 or 45, 45, 90. In order to use Pythagorean theorem, we have to have right triangles. So up until this point, we haven't learned how to solve or find side lengths or angle measures of anything if it's not a right triangle. So everything we do here, we will do to non-right triangles. Okay, so just to warm up, which will also help us as we go as well, we're just going to go through and do these four. So I'll do the first one. So all we're going to do is cross multiply like normal. Okay, now remember, your calculator knows what the sine of 28 degrees and the sine of 65 degrees is. Okay, remember, it's just a number. So when we cross multiply, I get 21 times sine of 28. That's going to equal a times sine of 65. Okay, to get a by itself, I'm going to divide both by sine of 65 degrees, divide by sine 65 degrees, so that goes away. So I get 21 times sine of 28 over sine of 65. Okay, now I can just put this in my calculator, and when I do, you should get that a is roughly 10.9. Okay, I'm going to go ahead and do 4 as well, just because it's a little bit different, because here we're finding a side length, or an angle measure. I'm sorry, we're not finding a side length, we're finding an angle measure. Now you have the tools to be able to do this, but just because it's different than number 1, we'll do 4 by itself. All right, so same thing as we did before, we're going to cross multiply. So I have 61 times sine of b equals 54 times sine of 73. Okay, we want to get b by itself, but remember, b is stuck with sine. Okay, so we're going to divide by 61, those go away. So I get the sine of b is equal to 54 times sine 73 over 61. Okay, now I know the sine of b is this. Remember, this is just a number, and our calculator knows what that number is. So in order to find the angle measure, if we know the sine, we want to find the angle measure, we would use sine inverse. And remember, when we use sine inverse, we reverse these. Okay, so sine inverse of 54 times sine 73 over 61 is going to equal the measure of angle b. Okay, and if we put that into our calculator, you should get b is roughly 57.8 degrees. All right, now I want you to go ahead and do 2 and 3 on your own, and then we will go over them. All right, let's go over these two. So on 2, when we cross multiply and do a little bit of algebra, we should get c equals 15 times sine of 94 divided by sine of 40 degrees. And when we plug that into our calculator, you should have gotten c is roughly 23.3. Realistically, guys, you're not going to get nice numbers for these. Most of these will be decimals, so we'll end up rounding them. And then on number 3, once again, we cross multiply. Do some algebra, we get b equals 63 times sine of 9 degrees over sine of 105 degrees. And we put that into our calculator, we get b is roughly 10.2. All right, guys, so this is just showing us an alternate way to find the area of a triangle, okay? And so the way we know now is 1/2 times base times height. But this is a little bit different. This is using trig ratio. So say we have a triangle like this below, or we don't, or here we do know what our base is, but we don't know what our height is, and we have no way to tell. Okay, so we can use one of these formulas. Now, these look like 3 different formulas, but really, They're the same formulas, just the letters are a little bit different. So basically, anytime you have two sides plus the included angle measure. And remember the included angle measure, so if we have a triangle, if I know this side and this side, the included angle is where those two sides meet, so this would be the included measure. Think of when we did side, angle, side. It's the angle between the two no sides. All right, so anytime we have that, we can use one of these, okay? And it's just 1/2 the two side lengths times the sine of the included angle, okay? So if I look at example 1, I know this is C, this is B, and this is angle A, okay? So B and C and angle A, I have all these, I would use this formula, okay? So I could say the area of this triangle is 1/2 B times C, and guys, I probably should have said, remember, opposite of angle B is side B, opposite of angle C is side C. That's how I know I had side B and C. So 1/2 times 17 times 19 times the sine of 135 degrees. Okay, now if I put that into my calculator, I get roughly 114.2 units squared. And that's it. All right, I want you to go ahead and do these next two examples on your own. Okay, these are just like the one we just did, except here you have to draw your own picture. So draw your picture. Remember, opposite of angle A is side A, opposite of angle B is side B, and opposite of angle C is side C. All right, so on your first example, you sketch it out. Guys, this does not have to be to scale. And your formula would be 1/2 19 times 14, so these are the two node side lengths, times the sine of their included angle, which is 60. You plug that into your calculator, you get 115.2 units squared, and that is rounded. The next example is 1/2 times 38 times 31 times the sine of 29 degrees, and when you plug that into your calculator, you get roughly 285.6 units squared. All right, guys, now let's look at the law of sines. Okay, now the law of sines we're going to use only with non-right triangles. Okay, sometimes this does work with right triangles, but not always. Okay, sometimes you will not get a correct answer. So we're only, for the purpose of this class, we're going to say we can only use this for non-right triangles because it always works for non-right triangles. And the law of sines can be written in one of two ways, either what's here on the left or what's here on the right. Now, I generally use this way just because this is the way I learned it and this is the way you see it most. It's the same thing, so it doesn't really matter. So law of sines basically says that side A divided by the sine of angle A has the same exact ratio as side B over the sine of angle B, which also has the same ratio of side C over the sine of angle C. Okay, now obviously when we set up an equation, we don't need two equal signs, we just need one. And so we don't have to use all the information we have. So let's do an example and it'll make a little more sense. All right, let's use this example here. So we want to solve the triangle. Okay, so when we solve the triangle, that means we want angle A, angle B, angle C, and then side A, side B, and side C. Okay, and I always write what I have. So side B is opposite of angle B, that's 11. And then I have angle A is 115 degrees. And then I also have side A, which is 20. Okay, so I'm going to go back here and I'm going to write here that we use the law of sines when we have an angle side pair. Okay, and what I mean by an angle side pair, that means we have side A and we have angle A. Or we have side B and angle B, or we have side C and angle C. Okay, so if we go back here, notice we have both angle A and side A. Okay, so that tells us we can use the law of sines. Okay, notice we have side B, but we don't have angle B. Okay, so I'm going to set up an equation. I know that A over the sine of A has the same ratio as B over the sine of B. Okay, now all I have to do is plug in numbers, guys. So my little a is 20. So 20 over the sine of angle A is 115 equals my B, my little b, which is 11 over the sine of angle B. Okay, from here it's back to what we did for our warm-ups, right? We cross multiply. So I can say 20 times sine of B equals 11 times sine of 115. I want to get B by itself, but B is connected to sine, so I want to get sine of B by itself. So I'm going to divide both sides by 20. I get sine B equals 11 sine of 115 over 20. Okay, now I have the value of my sine. I want the value of my angle, so I can use sine inverse. And when I use inverse, I flip these. Sine inverse of 11 times sine 115 degrees over 20. And that's going to equal my angle B. Okay, so if I put this into my calculator, I get that B is roughly 29.9 degrees. So I can say this is 29.9. Okay, now I have two angles, so I can find my third one because I know they all have to add to 180. Okay, so if they all add to 180, that means angle C has to be 35.1 degrees. Okay, and now that I have angle C, I can find side C. Okay, so I can use side B and angle B, but I'm not going to, because remember this 29.9 is rounded. So I'm going to go and use the non-rounded stuff when I can help it. So I can say that A over the sine of A is going to equal C over the sine of C. And then plug it in. So my little a is 20 over the sine of 115 equals my C, which I don't know, over my sine of, I do know angle C, 35.1 degrees. Cross multiply. So 20 times sine 35.1 equals C times sine 115. Divide by sine 115. Divide by sine 115. I get 20 times sine 35.1 over sine of 115 equals C. And then I can just put this into my calculator. And when I do, I get C is roughly 12.7-ish. So this is 12.7. I have now solved my triangle. All right, so I want you to go ahead and do these on your own. So solve this triangle. So I want you to find angle A, angle B, angle C, then side A, side B, and side C. Okay, and we're going to use law of sines. So we have a few. We have angle B is 25, side B is 15. So here's our angle side pair, so make sure you use that. And then we have angle C is 107. All right, so when you solve this, you should have easily been able to get angle A. Okay, it's 48 degrees. And then you could set up your proportions to find A is 26.4 and C is 33.9.